So we've made it to Unit 2 now. So the purpose of this unit is really to kind of analyze various forms of geometry. Namely, we're going to be looking at lines and circles and a few properties therein. But in order to do that, we need to go over some basics to make sure that everybody's on the same page before we even really get started. So in 2.0, we're looking at the prerequisite skills. So let's start going through this. We're going to start off by looking at what we have here. Let me just close that. There we go. Go away. There we go. All right. So the what of a line M, the slope of the line, the slope of any line, which we call M, measures how steep a line is and is the ratio of rise over the run. Now this is not new information. Basically, how far up and how far across do we go on each step. So the greater the magnitude of M, the steeper the line. So if you have a slope of 5, that's going to be a lot steeper than a slope of 2. A line with a positive slope rises to the right. It means it's going to increase up and to the right. Okay. Well, a line with a negative slope falls to the right. So it means it's going down and to the right. Great. A horizontal line has a slope of 0, which means it doesn't go up or down. It's just a perfectly flat line. So a horizontal line has a slope of 0. However, a vertical line, well, that's a little bit different. A vertical line doesn't have a slope. So what we say is a vertical line has a slope that is undefined. Undefined. All right. When, of course, we know that parallel lines never touch, so which means they have the same slope. Now, this is all information that we touched on in the last unit, including this last little piece. Perpendicular lines, so lines that intersect at a perfectly right angle, perpendicular lines have slopes that are negative reciprocals. Negative reciprocal of each other. Now, what do I mean by that? So imagine you have one slope that is equal to A over B. That means the perpendicular slope of that one, would be negative B over A. That's what the negative reciprocal means. You flip it and you multiply by negative 1. Okay? Of course, if it was already negative, then that would make it positive. So that's the key information that we need to kind of get started. So let's start off with some of the basics. Let's imagine that we have a line that has 2 points, A and B. A is at 4, negative 13, and B is at negative 5, 5. I want to calculate the slope. Now remember, the slope is simply the rise over the run. So our slope, little m, AB, the slope of AB, is equal to the rise. Well, what does that mean? The rise is the difference between the two y components. So we would write that as y2 minus y1. And the run is the difference between the x components. That would be x2 minus x1. When I say y2 and y1 is coming from the first point and y2 is coming from the second point. Does it matter what order? As long as you're consistent, it shouldn't matter. So as long as your ones are always coming from the same point and your twos are always coming from the other point, it shouldn't matter in that regard. It depends on what we're doing. So let's demonstrate this for a second, okay? So right here we have y2 minus y1, and that would mean we have 5 minus negative 13. And that would be over the run, which is negative 5 minus 4. And we do the math here. We have 5 minus negative 13. That's the same thing as adding, so that'd be 18 over negative 5 minus 4, which is negative 9. And that's going to give us a negative 2 as a result. If we went from B to A instead of A to B, now obviously the 2 points are reversed in that regard. So, but how would that actually change the math? Imagine that for a second. So if we have MBA like this, so that would mean that A would be the second point. So that would be, well, they would say, let's start at negative 13. And we're going to subtract 5. And then on the bottom, it would be 4, subtract negative 5. Now let's see how this changes things. Negative 13 minus 5, that gives us negative 18. And 4 minus negative 5, that'd be the same thing as adding, so that's 9. So what we end up with is, again, -2. The order, as long as you are consistent, will not make a difference. So the slope is still the slope because it's still the same line. Okay? Just be consistent and you'll be good. So going down a little bit, determine the equation of the line that has the slope of 2 and passes through the point -2, 5. Now, we know when we're talking about the equation of a line, we're talking about y is equal to mx plus b. So our goal here is to find y is equal to mx plus b. However, what do we know? We know we have the slope. So we know m. But we don't have b. We have a point, but we don't know what b actually is. So b is the y-intercept. That's definitely not the y-intercept because the x value is not 0. So how can we use this information? Well, think about it like this. If I have a value for m, and I know for a fact that this line passes through this point, if we substitute all those 3 values in, the only thing left is b. So we could actually calculate b by substituting everything that we know inside the equation. So that would mean that we would have y, which is 5, is equal to m, which is 2, times x, which is -2, plus b. Now I just got to solve for b. So 5 is equal to -4 plus b. Now when I bring that over to the other side, we end up with b is equal to 9. Now we have all the values we need. We have m, we have b, so we can finalize our final answer, which is therefore y is equal to 2x, which is our slope, plus 9. And there's our final answer. So we can determine the equation just by substituting the values that we have in there to find the only thing left out of this whole mess. All right, let's keep going. We're not done with the basics yet. We got a little bit more to go. There's actually quite a bit more basics that we have to have this, but we'll get through it all. So what do we got here? So our goal for the next piece here is steps to find the equation of a line when you know 2 points of a given line. So imagine what I'm saying here. I'm saying if I know one point A and I know another point B, whatever those values are, I can use those 2 points to determine the equation of that entire line. How? Well, very similar to what we just did. In the last 2 steps here, if we think about what we did in these 2 questions, example 1 and 2, we knew 2 points, so we were able to find the slope. In the second question, we said, hey, if we know the slope and we know any one other point, we can find the b. So we combine those 2 things together, and we can find the equation of any line as long as we know those 2 points. So steps to find the equation of the line when 2 points on a line are given. First up, we want to calculate the slope. Just like example 1. Once we have the slope, we're going to find the y-intercept by substituting the coordinates from any point that's on the line and the slope into our equation of a line, and we'll solve for b. And that's the whole thing. So let's do a demonstration of that in example number 3. Determine the equation of a line that passes through 2, 6 and -1, 7. So I got to find the slope. So our slope is going to be equal to y2, let's use 7, minus y1, which is 6. And that's all over x2, which is -1, minus x2, which is 2. I'm sorry, x1, which is 2. I apologize. And now we finish this off. 7 minus 6, that's a 1. And -1 minus 2, that's a 3. -3, actually, sorry. So we ended up with our slope of -1/3. Okay. How does that help us? We go on to step 2. Step 2 says sub m and one of our points. Does it matter which one? It absolutely does not. So we'll use 2, 6 since they're both positive numbers. Maybe it'll make our lives a little easier. And we're going to sub these things into y is equal to mx plus b. And our goal is to find b in this circumstance. Alrighty. So y, well there's 6, is equal to m, which is -1/3. X, which is 2, plus b. So 2 times this is going to give us 6 is equal to -2/3 plus b. So we got to bring that over to the other side. And since that bottom is a 3, I know in order to add with our 6 here, this thing is also going to need a denominator of 3. So I'm going to have to triple the 6 here. So that means this is going to become 18 over 3 plus 2 over 3 equals b. And what we end up with is, we're running out of space here, but what we end up with is b is equal to 20 over 3. So we have our b, we have our m, and now we can do our final statement. Therefore, y is equal to negative 1 over 3x plus 20 over 3. They're not the most beautiful numbers in the world, but they work just fine. A number is a number. Alrighty, so those are the basics. Let's keep moving. So now imagine that we have something a little bit more complicated. We're dealing with some basic lines. So this one says, determine the equation of a horizontal line that passes through 2, 3. Now think about this. If I draw the dot 2, 3, 2, so 2 over and 3 up, right there. What does this mean? It's a horizontal line. That means no matter what the x value is, y is always going to be 3. Well, that's it. That's the whole thing. So no matter what the x value is, y is always 3. So our equation when we're dealing with horizontal lines is always y is equal to something. What is the something? Well, whatever point our thing passes through. In this case, y is equal to 3. Now you could actually go through the long math and you could solve doing the exact same thing we did before. You're like, well, what do you mean? Well, we can calculate for the slope here. If we did that, we would say, okay, well, what other point does this thing cross between? It crosses between 0, 3 as well. We can see that. So if we found the slope between those 2 points, think about this. It's m, which is rise. So we have 2, 3, and we have 0, 3. Okay? So our rise is going to be 3 minus 3 over 2 minus 0. Well, that's just 0 over 2, but that's still just 0. It means we have a slope of 0. So in our equation, y is equal to mx plus b. Well, our m is 0. So the x goes away, so all we're left with is the y-intercept, which is just y is equal to 3. So that's what you're going to get every single time you have a horizontal line. Y equals one of the y values that it crosses through, whichever one, every single time. A vertical line is the exact same idea, except it doesn't have a slope, so it makes the math a little bit more ugly because you're going to end up with an impossible m value. So what we end up with here is the solution to any equation of a vertical line is always x equals the number of the point that it passes through, the x component of the point that it passes through. In this case, it passes through 4, 1, 2, 3, 4, 1. This is a vertical line, so that means it goes straight down here. No matter what the x value, or sorry, no matter what the y value is, x is always equal to 4. So that's your equation of your horizontal and vertical lines. Horizontal is y equals the number, and vertical is x is equal to the number. Alrighty. Let's go on. We got one more page to go through for our basic stuff. So write the equation of a line that's parallel to 2x plus y minus 5 is equal to 0, and it passes through a specific point, negative 1, 5. Now, parallel, what does that mean? It means that it has the same slope, but we don't know what the y-intercept is. All we know is it's parallel. It's very possible that it's actually coincident as well, but we're not sure. But we can get the slope from this line. Let's rearrange this equation and find its slope. So this equation, which is just 2x plus y minus 5 is equal to 0. We can rearrange this, so we keep the y on the left-hand side, and we're going to bring the 2x minus 5 over to the other side. So we have y is equal to minus 2x plus 5. So our m in this situation is equal to negative 2. Oh, they're parallel lines. That means the m in my other line, the line I'm trying to write the equation for, also has a slope of negative 2. That just means that I need a y-intercept for it. Good news, we know that it passes through that point. So we can do the same thing that we've been doing before. Substitute both the point and the m into our equation of a line and solve for b. So our y is 5 is equal to, where'd I go? So let's actually write out what we're doing here. just to make sure it's clear. We are going to sub m and our point, which is -1, 5, into y is equal to mx plus b. And our goal is to find b, because it's the only thing that's going to have a value when we're done here. So y is going to be equal to 5. Our m is -2. Our x is -1. And we're going to add on b here. So we have 5. Now this is -2 times -1, so that's just 2, equals 2 plus b. So that means b is equal to 5 minus 2, which is 3. So now we have our y-intercept, we have our slope, so we can finish off. Therefore, y is equal to -2x plus 3. There we go. Next question. Write the equation of a line that's perpendicular to this statement. Okay, same idea, but now what we need is the slope of the line that's perpendicular, which means negative reciprocal. So first up, we got to find the slope of this line. So we're going to rearrange it. So we have 3x plus y minus 6 is equal to 0. Now we're going to rearrange it for y. So y is going to be equal to -3x plus 6. So that means our slope m is equal to -3. Or another way of writing that is -3 over 1. So what does that mean for our slope of our perpendicular line? We flip the fraction and we flip the sign. So it becomes 1 over 3. All right, we have a slope and we got a point. So we do the same thing as before, sub them in. So we're going to sub m perpendicular and 5, 2 into y is equal to mx plus b. Alrighty. There we go. Where were we going? So now we just got to substitute all the values. So our y is 2. Our slope is 1/3. Our x is 5 plus b. Now we can't, we're going to multiply this through. So we end up with 2 is equal to 5 over 3 plus b. We're going to bring that over to the other side, but our 2 needs a denominator of 3 as well. So we're going to multiply the 2 by 3. So we're going to have 6 over 3 minus 5 over 3 is equal to b, which means b is equal to 1/3. All said and done. Therefore, y is equal to 1/3 x plus 1/3. And that's the entire equation. Great. So down here you see a bunch of practice problems for you to try. It just kind of works through, and the solutions down below, so you can work through there. That's going to be it for our preliminary lesson on analytic geometry. We're going to use and apply all of these skills going forward for the rest of the unit, so make sure you're ready to go.